I will let my colleagues, Jonathan, Mayank, and KJ, to lead you through the next session on the immersion session with our Digital Capability Center. Jonathan, over to you.
Hey, thanks, Alpesh. Hope everyone can hear me. Morning again. My name is Jonathan, and I lead the DCC for Singapore for McKinsey. And just building on from what Alpesh has articulated, right? The opportunities are there for Industry 4.0 adoption. Companies can create a competitive advantage by adopting digital. And I think really the question around the asymmetry in adoption is, the real question is how to implement, right? I think in response to this, on the next page, McKinsey has built a network of centers to really help, next please, to really help companies navigate through this digital journey. If you look across our network, we have more than 10 centers today, and this network is growing. And really the objective is to help companies think through how to adopt, what to adopt, and how to build that muscle to implement this digital initiatives, right? On the next page, let me say a little bit more about how DCC Singapore specifically is, what our role is, right? Next page, please. Yeah, thanks. So the DCC really is a catalyst to help companies along their digital transformation journey. In Singapore specifically, the DCC here is a collaboration with the EDB and A-Star. Physically, we are located at ARTC, the Advanced Remanufacturing and Technology Center. The objective of the DCC Singapore really is to help companies accelerate the adoption of digital, right, across different industries, across regardless of size of organization. So we work with large corporations as well as SMEs. And really part of the role of the DCC is also to create a marketplace for the solutions, for digital solutions in this region. How we do this really is along 6 dimensions that you can see on the right-hand side of the page. First of all, we're a physical showcase of how a company that is going digital, and we try to articulate that journey to help companies understand what is required. Right? My colleague Mayank afterwards will share with you a bit more detail about some of the use cases that we have on this physical showcase itself. Secondly, we recognize that once companies understand what is required, very often companies also then need to build capabilities in order to execute these. Right? So the center is also structured as a capability center to help companies build that muscle to execute. Right? And really the key elements of capability are around understanding what is required in terms of business transformation. So what is the business case for adopting digital? Secondly, what is the technology landscape out there? What are the technology opportunities and how should companies think about technology? And thirdly, also equally importantly, is organization. How do you mobilize your workforce? How do you mobilize your operators? It's not just about a pipe dream of a senior team. It's really how you bring along the entire organization to execute. Thirdly, to help companies find, scout, evaluate, and find some of these technology partners. At the DCC Singapore, we have built up an ecosystem of solution partners. Most of these are startups, although we do have a handful of fairly large technology providers. We're happy to share some of these with you afterwards when Mayank talks about the use cases. Fourthly, we're also what you call a delivery center, in the sense that we help companies get started on their Industry 4.0 journey. And really the first step is a diagnostic to baseline the company's sort of current state of operations and to identify opportunities and prioritize those opportunities. Number 5, we're also an innovation test bed. So, from time to time, we do have companies that want to test out solutions in a safe environment, away from their own premises and away from their plants, to really understand the impact of a solution, right? So, by virtue of the fact that we have a showcase, we have a physical production line that can be used, we can instrument it up, we can deploy solutions to evaluate what is the impact before applying these technologies to the real life situations. And number 6, we also have partnerships with companies that have succeeded in their digital transformations. So DCC Singapore has got partnerships today with 3 of the WEF, or World Economic Forum, lighthouse sites, 2 of them in Singapore, Micron and Infineon, and the third in Batam. Having COVID and the travel restrictions makes it a bit difficult to do some of these physical visits physically, but we have been able to establish virtual go and see visit partnerships with these companies. So we now can virtually visit them, and as part of the learning journey and understand what are some of these success factors about, we're more than happy to set up visits to these companies, right? And moving on to the next page, if I can talk a little bit more about the DCC physical showcase itself, right? The showcase, the showcase essentially centers around a gearbox production line, right? It can be any production line, but we've chosen to a more industrial setting, and we have brought in a physical gearbox assembly line, right? To demonstrate productivity improvements that can be made from in moving from a lean state, which is non-digital, to what we call a digital lean state in a brownfield context, right? So the starting point really is an assembly line that is already high performing, right? It is already a lean operation to begin with. It uses some of the key lean principles around just-in-time, single piece flow, work cell design, etc. Right? And the idea is to demonstrate how companies can move from an already high performing state, lean, to, by instrumenting up and applying digital solutions, how you can improve productivity further. And the research that we've done at the DCC Singapore has shown that in a brownfield context, meaning you don't demolish your current factory, but rather you retrofit technologies onto your existing line, we're able to improve productivity by 40 to 50%, right? Which is, if you think about it, which is quite significant, right? Because we're moving from a lean state and building upon it. Okay, and some of the technologies and the solutions that you will see are very sort of commoditized solutions, like sensors, human interfaces, software solutions, digital SOPs, etc. Right? So if we go to the next page, before sharing with you some of the specific use cases, let me just say a little bit about this gearbox assembly line. Right? You can move to page. Yep. Thank you. So if you have the opportunity to visit the DCC, this is what you'll see on the production line. It's a gearbox assembly line, and let me just orientate you. The production flow goes from right to left. So and there's 3 stations. On station 1, which is on the far right, that is if you think of a gearbox. You have gears and bearings and a shaft and also a box to put it inside, right? The station 1 essentially is the gear and shaft assembly station. So that's where you put the gears, the bearings and the shaft into a package. And this is where we demonstrate technologies like digital twins, the use of automation and cobots in order to improve productivity. Then moving down the assembly line, station 2 is the cover assembly or the casing assembly. So if you look at the gearbox, there's an outer shell of it, and station 2 essentially assembles that outer casing. What we demonstrate here is technologies around intelligent material storage, inventory management, the use of wearables such as Google Glass, some of these devices in order to improve the management of inventory and also productivity on the shop floor. Then moving to station 3, which is the final assembly station, this is where the gear and shaft assembly package goes into the gearbox casing. There's lubricants that are applied, final inspections to make sure that the setup is correct. And then finally, there's the sealing of the gearbox itself, right? So on station 3, we showcase a different set of solutions, given that station 3, opportunities to improve productivity are fewer because it's more around quality inspections. It requires human judgment, etc. So here we showcase digital assistance systems, digital SOPs, wearables for the operator in order to understand the ergonomics of the workbench for the operator. Okay, so just a quick orientation to what the gearbox assembly line looks like. I'll hand you now to Mayank, development manager, to take you through a couple of these use cases and help you understand, what is the impact that can be achieved using some of these solutions. Over to you, Mayank.
Thanks, John. And thank you, Alpesh, as well for the introduction to Industry 4.0 and the DCC over here. Next up, we want to give you a little bit of a preview of some of the solutions that are on the DCC shop floor that John just spoke about. In specific, we are going to look at 4 of these today. The Digital Performance Engine, which is a tool to quickly enable digital performance management to improve OEE and overall productivity on the shop floor using some basic IoT type of technology. Digital SOPs, or digital work instructions, as you might have heard about it, to help workers on the shop floor perform their activities better. Looking at workforce tracking system for both physical and time-consumed tracking of the activities that help on the shop floor. And finally, we'll look at one of our sort of a little bit more advanced use cases, which is condition-based monitoring for equipment which can be helpful in preventing downtime and failures. So with that, let's get first started with the first one, which is Digital Performance Engine. Before we actually get into the demo, just a quick intro on that. This is one of the most basic, simple on one hand, to the most impactful use cases on the other hand, and even more so in the context of COVID-19. So traditionally, if you imagine performance management on the shop floor happens through manually collected data on productivity performance, whether it is OEE, OPE, some of these KPIs that you might be familiar with, putting them on sort of charts which are made through either Excel or manually, and then having a conversation about it either at the end of the day, end of the shift, or end of the week. I think while that is sort of a way which is still effective, but it takes a lot of manual work, it takes time, and it is not real time. And it lends itself to be very challenging, especially in a case like COVID, where you don't necessarily have the type of manpower required on the shop floor to do all of these activities. In that context, if we have basic IoT type of technology that connect to PLCs or that add sensors onto existing machines, collect the data, and contextualize it in the right format, right analysis at the right time in real time, can be super powerful. So let's quickly shift to the demo for DPE. With that, Vicky, can I ask you to
Welcome to Gearbox Core Assembly Line Stations 2. As mentioned, what we are doing at Stations 2 is to assemble the final gearbox. The gear and bearings that are prepared at the Station 1 will be passed to the Stations 2 together with the casing to assemble the final gearbox. So traditionally before the DPE solution in place, the shop floor supervisors do not have the visibilities of what is the operation status of these stations. For example, you don't know how long it takes for each operator to finish each task, aka cycle times. Also, because this station is used by different operators, we do not have the visibility like each operator, what is their variation in terms of finish the same task. And because we also assemble different kind of gearbox in these stations, we also do not have the visibilities of how long it takes to finish different kind of gearbox. So by simply implement an IoT solutions, you can have all these informations captures. Here, I want to introduce one of the solutions that we implement in this station is called the IoT Solutions. So IoT Solutions consists of 4 main components. First, we have the light sensors that install to track whether the gearbox casing is on top of the dolly or not. Then the data will be transmitted to the edge node. So the edge node can connect up to 6 different channels. Same understanding can connect up to 6 different kind of sensor also. And notice that the edge node have the antenna. So what it's doing is to transmit all the information to the gateways. So the gateway is like a middleman of the whole system. It transmits all the data and push it to the cloud to be stored at the cloud. So what we are seeing here is the dashboard of the Iot Solutions. It have all the information captured to show that whether the station is running or not. Currently, because the station is running, so you can see it's in red colors. At the right hand side, we can see it captures the OE information of these stations. OE calculations taking in 3 parameters into calculations: the availability of these stations, the performance of this station, and also the quality of the products produced by these stations. So when the operators come in and start using the stations by taking out the gearbox casings, all this information will be captured by the laser sensor. The laser sensor will detect currently the gearbox is not on the dollies. Then it will pass the information to the cloud in real time, and the shop floor supervisor will also have this information, have this visibility in real time. Yeah, you can see now it indicates that currently the station is running. So what is the benefit when you have this system in place? First, you have real-time information of your shop floors. Imagine now you are able to know currently in current situations whether this station is running or not, and how fast the operator is finished each of the gearbox. And another one is very important during current COVID situation is because this is a cloud instance. The supervisors or managers are able to access the dashboard anytime, anywhere. Be able to access this in the home or in the office, and no need to be physically present to monitor the operator to make sure they are working. And lastly is because now we have captured all the data, and all this data are stored in the cloud storage. You're able to use this data for further analysis in the futures. For examples, if you have data scientists, we are able to pass this information to the data scientists to build a predictive models on some of the tools that we are using in these stations. So welcome to the station 3 of Gearbox called assembly lines. So as mentioned, at these stations, we are
All right. So that was just a quick view of the digital performance engine tool that we have at the DCC. I think later on we might talk a little bit more about it in an IHCI context. But hopefully that gives you a view of what these solutions could look like. And also more importantly, what the range of implementation could look like, from something very simple that still adds value to something that enables more advanced predictive analytics that uses, artificial intelligence or machine learning to draw out insights or to be able to predict outcomes on machines, etc. We will go to the next solution now, which is on digital SOPs, and try to give you a view of how simple digital technology like iPads or projected work instructions can be used to empower the shop floor worker who is performing all kinds of activities, whether it's production related or maintenance related, on the shop floor. With that, Vicky, can we switch?
Conduct the final QC checks to make sure that the final gearbox are in good condition before it pass to be stored in the inventories. So in the gearbox quality assurance, we have 14 steps that the gearbox, that the quality assurance operators will need to follow to make sure that each of the steps are go through. So traditionally, without a digital SOP in place, we have a hard copy SOP just put on the tables for the operator to refer to. Then we have this QC form for the operators to fill in to make sure that they follow through each of these steps, make the necessary ticks, and report any issues or remarks or any problems they face in each of the steps. So what are the pain points that you will face when you use this kind of manual SOPs? First, for the high mix, low volume kind of situations, your QCs for different kind of product will change frequently. Then, using the hard copy solutions, you're not able to capture all this information in real time as fast as possible. Second, because now you only submit the form at the end of the days, or sometimes for some company is at the end of the weeks. So all of these QC reports is not passed to the managers or supervisor in real times. The manager and supervisor do not have the visibilities on how the defect rate of the products they produce at the whole assembly lines. That imagines that something wrong that's at the station too, and all of this information will only be captured at the end of the weeks, then it already causes unnecessary loss to the stations or to the organizations. Last, for this QC consists of 14 steps. For a lot of the supervisors, they want to know each of these steps, what are the cycle times that takes to finish each of these QC steps. And all of this information will not be able to capture using a hard copy solutions. So by using a digital SOP solutions, you're able to do that. So what we are doing here is to use Tulips to implement these digital SOP solutions. So Tulips is a manufacturing apps. You can create different kind of apps to suit your use case in the shop floors. For this use case, we install and build digital SOP solutions for station trees. So what the operators now need to do is just using the apps to follow through the steps, and he can use this as to call for help and also to report defect. Yeah. So if he face any defects, he can describe the defect types, capture the defect photos, and send to the supervisors. So what are the advantage of when you're using the DSOP systems? First, you're able to capture the information in real times. Once you submit the forms immediately after each of the products, the supervisor will have this information in hand, and if there's something wrong, the supervisor can immediately take actions to come down to the shop floors to investigate what happenings causing a surge in defect rate, for example. Then second, the supervisor can do this anytime, anywhere, especially during the current COVID situation. It's very hard for the supervisor to physically present to the shop floors to make sure that the QC are being done properly. So all of these informations using Tulips, it will able to have these informations stored at the cloud, and what the supervisor need to do is just log into the system to see how everything is working. Third, it's very important also is you are able to update the your SOP very fast just by using Tulips online editors. So Tulip online editor is very much plug and play. It's it just drag and drop. You can change the picture, you can change the instructions. It's a software based. All of this can be done within minutes or within 1 or 2 hours. So it's for high mix low volumes industry is very suitable for them to build different kind of DSOP system.
So moving on to the next one, which is a solution called No, which is used for workforce tracking. And again, this is a very simple solution that can be quite value adding on the shop floor. It can be used to enable operator check-in, check-out on workstations, or submit maintenance requests, ensure that the maintenance crews attends to the right site and carry out the work, and so on. So let's shift to the demo of this app and look at what it can do.
All right, let me introduce you another use case that we at the station 3 that we use a workforce tracking systems to facilitate some of our work. So traditionally, without these systems, when there's some maintenance issues happen at the station 3s, the operators will raise the issue by either using a phone call or using a WhatsApp message and send to the maintenance workers. So there's a problems when using this kind of traditional methods. First, the maintenance of workers might not picking up the phone because he's busy. And second, the WhatsApp is not designed for this kind of systems. When there's a lot of message in the WhatsApp, sometimes the maintenance worker will overlook what he need to do. So by using the system that's specially designed for this, you're able to, which is no nugget, you're able to raise an issue through the systems and also able to track whether the maintenance worker are checked in at the locations to conduct the maintenance work. So let me bring you to see how we implement this in our station 3. So currently we have this operator working at the station 3 using an automated screwdriver to screw the gearbox casings. So at the middle of the work, he noticed that the screw drivers have some issues. It cannot screw tight, facing some problems. So at this point, he can use the no-nugget apps to raise an issue to inform the maintenance managers station at the workshop to come and help him to solve the issues. So he can go in and raise a new issues. He can select what kind of issue he faced, is the damage. Then he can give a title to these issues. It's a screw damage. And of course, he can assign severities. It's a medium severities. Then he can give a simple description of the issues, like it can't screw the protect at the station 2. So this information will give maintenance engineers a preparation before they head down to the site. We also can track the location of where the station is, and this also gives the information for maintenance engineers. And notice that he also can take the pictures of the problems that happened. So this also gives a very good info for the maintenance engineers before they head out to the site. So once he collect all this information, he can simply send the issues to the maintenance worker. So notice here he can select who are the people that he want to send. Now we are sending to all the people. So you can assign different users groups in using the apps and send to them accordingly. So now a new issue has been raised and the maintenance engineer will come and help him out. Yeah. So now imagine I'm the maintenance engineers that stations at the workshops prepares to carry out the maintenance work. I will have this no-nugget dashboard that shows me what are the current open issues and how critical is the issues and which department raised the issues. Then from the issue tabs, I'm able to know what are the issues that's currently open. So this is one of the issues that's raised by the station 3 just now. From here, I can understand what are the issues, what is causing the issue, what is the issues, some description on the issues, and the pictures of the issues. From here, I can do some preparation work before attend to the site. Then I'm able to also know the locations of the issues being raised. So with all this information gathered, I can do some necessary preparation before head down to the site to carry out the maintenance work. Now, imagine I'm the maintenance engineers called by the operator at the station 3 to come here and help him out to solve the problems that he faced at the station 3 just now. The first thing when I reach the station is to inform my maintenance managers that I reached the correct location and start carry out my work. So I can simply use the no-nugget apps to check in. And notice that the apps that have these selfie features that allow you to take your own photo to make sure that you are the right person to carry out the work for record purpose in the future. So because of current COVID-19 situation, it also comes with these safe entry QR scanners to allow you to scan the QR code and check in for safe entry check-in. So after you do all the necessary check-in, you can start carry out your maintenance work. So all of this location information will be captured by the apps and sent to the dashboard at the cloud. So your maintenance managers will know how's the maintenance crews doing around the island.
So I think one thing that I want to revisit at this point of time is, just as we talked about earlier, that the solutions can be simple, but that can enable more sophisticated use cases and more addition of value later on as the digital transformation matures. I think that is very visible here as well, not just in the form of more advanced analytics, but also in the form of going beyond the point of use. So while reporting of a maintenance issue is one, sending it to the maintenance staff, linking it to the spares management, doing analysis on it after the fact and seeing what are the major reasons for failure, being able to systematically improve the operations are all sort of sources of value that can be enabled by this simple solution that can start small, but that can enable more and more value addition as it cuts across the functions within manufacturing or even beyond manufacturing. Let's look at our last solution, which is on condition-based monitoring systems. Again, in the context of COVID, this is important because it enables companies, managers, shop floor supervisors to keep a track of the machine performance, to keep a track of what are the issues, what is causing failures, and most importantly, what can potentially cause failures, and be able to red flag that even before the machine failure occurs. The way the solution is set up is through a simple system of sensors going through an advanced analytics algorithm that are then able to predict a percentage chances of failure for a particular equipment depending on the running conditions. If the temperature, vibration, sound, etc. become too high, then it can raise an alarm and enable preventive maintenance rather than breakdown maintenance. So let's look at the solution now.
Let me introduce another solutions, another use case that we implement in the DCCs. It's called a condition monitoring. So at the right-hand side is the NTS 1000 CNC machines, which we use to manufacture or process the gear and the bearings to be used at the assembly line. So what we are doing here is to implement a condition monitoring systems to monitor the condition of the machines. So from our studies, we noticed that the CNC machines, there are main 5 components that are causing most of the defect. The bearings, the ball screw, the slide, the servo motor, and controllers. And each of these components have different defect characteristics. And when we study, we do a deep dive study to understand the defect characteristics and the defect rate. We notice that the ball screw are causing most of the defect. That's why in these examples, we install vibration sensors to track the condition of the ball screws to make sure it's fall within a good operating threshold. So the thing is, when the ball screws are used frequently, it will causing wear and tear, and this wear and tear will also causing the vibration amplitude to either surge up or go down. So we have installed 6 vibration sensors across 3 axes of these ball screwdrivers, and from the historical data, we're able to know what are the upper threshold and lower threshold that this vibration sensor can go. And from here, we're able to know whether the ball screw are in a good condition when they are operating. So when the blue axis here actually showing the amplitude of each of the vibration sensors. So once the amplitudes are cross a certain threshold, then it will indicate that there's a abnormal ball screw vibration here. And from here, it will also alert another work orders to our maintenance workers that what should be done to calibrate the ball screwdriver so it will fall back to the normal operations. So the companies that will benefit for this kind of solution normally is a more advanced companies. So for those companies that do not have a good ROIs, then normally we will install a cap-based to extract the sensors data directly and do analysis from there.
All right, so that was just a quick demo of 4 of the solutions that we saw. Moving on to the next page. We'll do a quick poll and try to see from these 4 solutions that you just saw what excites you the most. What do you think will drive a significant value or could drive significant value in your organizations? All right. I think quite encouraging to see a number of people feeling that all of the above solutions could add significant value. And other than that, I think digital performance management also is something that we have seen in other situations being the most simple yet most valuable Industry 4.0 solution that can add a lot of value, as well as digital SOPs and workforce tracking systems. So I think this is quite in line with what we have seen in other places, and even in the few set of companies that we have gone through in the IHCI program over the last few months. We move on. I vote.
Yeah, thank you, Mayank.
Alpesh, over to you.
Yes, thank you. Thank you very much, Mayank. And maybe just one quick note before we move on. I understand that there has been a little bit of a glitch with the links, and that some of you were not able to join us until 20 to 25 minutes into the webinar. So our apologies for the confusion. And we've recorded a session. So for those of you who are interested, just let us know through the chat to Sam XHDan if you're interested, and we'll be more than happy to share the recorded part of the webinar later on with the introduction. So for those of you who have missed it. I also noted there has been a question that came in during the DCC demonstration around basically the fact that different tools have been demonstrated, such as No and Tulip. And there's a question about which platform then to use, and whether you need to build a platform in-house versus buying existing tools. So we're going to tackle that question actually in the next section. So I will hand over to Ting Feng Ye, our project manager for the HCI program. He will start with a little bit of the challenge to adoption, and we'll tackle that question there. And more than happy to take it further if it's needed. Ting Feng, over to you.